Hi there, my name is Daniel, and today I'll be explaining linked lists. I like to think about linked lists as a sort of scavenger hunt for your computer, and so let's start off by doing a scavenger hunt of our own. Let's say that you start off at your home, and I've hidden $100 somewhere. I tell you your first hint is to go to the library, however. So you walk from your home to the library, and at the library you open up one of your books, and you open up the book, and the next hint is to go to the coffee shop. So you walk from the library and go to the coffee shop, and at the coffee shop, underneath one of the tables, you find another hint which says to go to the gym. So you walk from the coffee shop to the gym, and finally at the gym, you find your $100. So what did we do in the scavenger hunt? Well, we started off with an initial location and an initial hint. The initial location had the hint, which told you which location to go to next. So we started off at the house, the hint was to go to the library, then to the coffee shop, and then to the gym, which was the final destination. Linked lists are pretty much the same thing. It's a scavenger hunt. Think about every single one of these little rectangles as a place. Just like how we have the house, library, coffee shop, and gym, we have these little rectangles. Each of them has a piece of data. In this case, it's a word, a string, and it also has a hint in it of where to go to next. So right here, we have a purple square inside of this node. That means that once you're at this node, the next node to go to, the hint is to go to the next purple node. Right here, we have like a green square. That means that the next place that you go from here is to the green node. Okay, so let's start off on the scavenger hunt. So your initial location is right here, this. Since the hint here is purple, you travel from this node to the purple node. The hint here is red, so you travel from the purple node to the red node. The hint here is green, so you travel from the red node to the green node. And finally, the hint here is black, and black points to a null pointer. Now remember, computers are not the same as humans, so when we did C-style strings, for example, we had a sentinel at the end of it to tell the computer that our string is over. Stop looking for more characters. It's the same exact thing in the scavenger hunt. We point it to this empty address, right, this null pointer, to say the scavenger hunt is over. You found all of the different places to be, all the different nodes, and that's how the computer knows to end it. Cool. So this is, in essence, what the point of a linked list is. Now, a linked list is a type of container ADT. So if you remember from earlier in the year, we learned about arrays and vectors, which are contiguous ADTs. That means that for every element, they're kind of stored next to each other in memory. However, linked lists are dynamic, and also they're scattered throughout, as you can kind of see in this diagram. The way that we kind of go from one element to the next is through the hints, however. The benefits of this is that we can insert a new value into the linked list very, very easily. For example, if we had an array that said this is a secret, it would be really hard to change it to say this is a special secret. Pretty inefficient because you'd have to make a new array, kind of resize it, and kind of copy everything over so that special is here and then you shift over secret. But for a linked list, what we could do is that we could make it so that this is A, and then from A, you point to special. So the way that you would point to special is instead of having a green hint, you have a blue hint. And then in order to continue on from special, now you have this is a special. You want the special to have a hint of green. And then that points to secret. So now you have this is a special secret. So just like that, you're able to insert a new value into the linked list. Now that is why we use linked lists. The implementation details for linked lists are listed here. You'll find them pretty helpful for project 4. Just one important note is that since you're working with dynamic memory in linked lists, you will need the big three. So notice here that I have put an asterisk next to the constructor. You're going to need a copy constructor, as well as a destructor and an assignment operator. And here's a variety of different functions that you may be using, like get first, which gets the first node, like this one right here, where we started at, or pop front, get rid of the first node, so you change the first node to be is. Push front, adding another node to the front, push back, pop back, etc., etc. The implementation details will be in the specifications for project 4. As for some real life examples, but as for some real life examples of where linked lists are useful, you might use them in a music player, for example. A music player essentially has two pieces of data. The music, the song that's playing, as well as what song to go to next. So if you think about your Spotify playlist or Apple Music playlist, the piece of data there would be the song that's currently playing, and then the cue, the thing that's going to happen next, is going to be the hint. So yeah, and in your Spotify or Apple Music, remember that you can kind of go back and forth in between songs. So you might want to make a doubly linked list. A doubly linked list is just a linked list, but instead of only having a hint that points to the next thing, you might have a hint that points backwards as well, so you can kind of rewind your song. But that is something that you'll kind of learn more as you kind of progress through Project 4. That pretty much covers what linked lists are. Thank you for listening to my video.